Welcome to the deep dive. Today we're going to try and dissect one of the most critical and honestly one of the most confusing terms in modern tech, DevOps. If you work anywhere near a software team, you hear it all the time. But what is it, really? Is it a buzzword? A job title?
Yeah.
Or is it something bigger?
That vagueness is exactly what we need to cut through today.
Yeah.
I think a lot of people hear DevOps and they immediately think of, a list of tools or some software you can just buy.
Right.
So for this deep dive, our mission is to get past that. We're here to give you a really clear understanding of the cultural shift, the mindset, and the kind of systems thinking you need for continuous software delivery.
Okay, let's unpack this. So we're starting with the historical pain point, the absolute chaos that came before this, and we'll follow that all the way to the infinity loop that defines modern IT.
And by the end, our goal is that you won't just know what Jenkins or Kubernetes are. You'll understand the fundamental problem they were actually designed to solve, and why that matters to the bottom line of really every company today.
Let's start right there, with that problem. Before DevOps, the tech world was kind of a cold war between two camps, development or dev.
And IT operations ops.
And developers would write their code, get it working on their own machine, and then they'd just throw it over the wall to ops.
And that single action, was the birthplace of so much inefficiency, both culturally and technically. The developer's happy, right? Their code passes all their local tests.
They say the famous line,
"It works on my machine." But ops, who are on the hook for keeping the live application stable and performing well, they're left holding the bag.
And they're seeing things like, database deadlocks, servers crashing.
Exactly. Unexpected spikes in load, weird app crashes that only happen when a real user is clicking around, things the developer never saw.
So I'm curious about the human side of that. When you have these two teams facing a crisis, how did they handle that friction?
Oh, it just immediately descended into finger pointing. The blame game.
Of course.
Devs would blame ops for, having the wrong server configuration or an old patch. Ops would shoot right back and say the code was unstable, that it couldn't handle the real world.
And management is just stuck in the middle.
Stuck in the middle of a blame game that's costing the business time, money, and, customer trust.
So why did this wall of chaos, as you put it, stick around for so long? Was it just people being stubborn, or was there a deeper technical reason?
It was a mix of both. Technically, the environments were just wildly inconsistent. A developer's machine looked nothing like the testing environment, which looked nothing like production.
That's called environment drift, right?
That's it, yeah. And culturally, their goals were completely misaligned. Dev was incentivized to ship new features fast. Ops was incentivized to keep everything stable, which meant avoiding change.
Those two things are fundamentally opposed.
Exactly. And the business consequences, as our sources point out, were just brutal.
Yeah.
We're talking about releases maybe every 6 months, if you were lucky.
And bugs are being found by who? The actual customers.
By your customers. Calling your support line. The risk was just huge. Deployments were these manual high-stakes rituals, usually late on a Friday night.
The worst time.
The worst time, where one single wrong command could take down an entire system. There was no real feedback loop, just customer complaints telling you something had broken.
It sounds like juggling flaming swords while blindfolded.
That's a pretty good description. That level of manual risk was the clear motivation that something had to change radically.
So if the problem is that the silos, the inconsistency, the manual work, this brings us to DevOps. And let's just say it again right up front. Yeah. DevOps is a philosophy. It is not a product you can buy.
Absolutely. We have to start simple. DevOps equals development plus operations. It's a movement, really.
Yeah.
A cultural and technical movement to bridge that gap with automation and new practices, all for one goal: making software delivery quick, safe, and continuous.
Okay, so this new philosophy, it's built on 3 key pillars. Let's walk through them. First up is collaboration. This means Dev and Ops stop being separate teams. They become one team. They have shared goals, shared accountability.
The second pillar is automation. This one is huge. The rule is simple. If you have to do something more than once, you automate it.
Building the code, running tests.
All of it. Configuring the servers, deploying the app, gathering the data.
Yeah.
You automate the repetitive, error-prone stuff so your smart people can work on, smart people problems.
And that brings us to the third pillar, continuous improvement. This isn't just a poster on the wall. It's a real commitment to learning from every single failure and every success.
It demands that your teams are actively looking for feedback and then immediately using it to make the process and the product better.
I think the restaurant kitchen analogy really helps make this concrete. The old way was like the chef, the developer cooking a dish.
And then just putting it on a dumbwaiter and sending it blindly out to the front of house staff who are ops.
No communication. But the modern DevOps kitchen is totally integrated. The chefs, the devs are still creating the dishes, but now the operations staff are right there with them, helping to standardize the process.
Right. And automation is all the high-tech kitchen equipment. The ovens, the dishwashers, everything that makes sure every single dish comes out consistent and fast.
And crucially, that continuous improvement is the waiter telling the chef immediately that a customer thought the chicken was too dry.
Exactly. The chef knows in minutes, not weeks, and can adjust the recipe on the fly. That immediate feedback loop is the absolute core of continuous delivery. It's what turns the whole process from something slow and sequential into something dynamic.
And that dynamic process is shown perfectly by that visual metaphor you always see, the infinity loop. It's not just a cool graphic, it really represents that flow of continuous iterative delivery. You're never done. You just move from one cycle of improvement straight into the next.
Let's trace that journey through the loop. There are about 7 main stages. And it starts, of course, with plan. This is where the team defines features, prioritizes bugs, and figures out what they're building in this cycle.
Okay, from plan, we move to code. Developers are writing code, but the critical part here is that they're constantly committing their changes to a central version control system, something like Git.
And you can't overstate how important that is. Without a shared system like Git, the collaboration pillar just completely collapses.
So after code comes build, this is where continuous integration, or CI, really kicks in.
Right. A tool like Jenkins or maybe GitHub Actions automatically pulls that new code, compiles it, and packages it into something that can be deployed. This is happening constantly.
And if the build fails, the team knows right away, not days later.
Instantly. And right after a good build, you get to the test stage. And this is not some manual QA phase at the end of the project anymore.
No, this is highly automated. Unit tests, integration tests, performance tests, running on every single change. But this is also where a new huge idea comes in, DevSecOps.
Yes, precisely. DevSecOps means security is no longer an afterthought, an audit you do right before you go live.
You're shifting security left.
You're shifting it left.
Okay.
They're baking security scans for vulnerabilities and compliance right into the test stage. It's so much cheaper and easier to fix a problem there than when it's already in front of customers.
Okay, so a build passes all these automated quality and security checks. Now it moves to release. What does that mean?
Release means the approved build is staged and verified in an environment that is a perfect mirror of production. This is the key difference between continuous delivery, where software is always ready to deploy, and continuous deployment, where it just deploys automatically.
Got it. And then comes the actual deploy stage. This is where the ops tools really shine.
Yeah, this is where you're pushing the application out. Often it's packaged in containers, using Docker, and managed at a huge scale with something like Kubernetes.
And that container idea, that finally solves the "it works on my machine" problem, right?
It's the solution. You bundle the code and all its dependencies together. It's one portable unit that will run the same way everywhere.
And finally, what closes the loop is monitor. This is the lifeblood of that third pillar, of continuous improvement.
It is. Teams are tracking the application's health, collecting logs, analyzing performance, all in real time.
And the key part is the feedback from that monitoring. That data flows directly back into the plan stage for the next cycle.
Exactly. If performance dips after a new feature goes out, you don't wait for a customer to complain. You see the metrics immediately, and a fix becomes the top priority for the very next iteration. The loop is truly continuous.
This all sounds incredible in theory, but let's connect it to the business. Why is every big company pouring money into this culture? It has to be about a competitive advantage.
The benefits are, they're transformative. Let's just start with faster releases. The classic example is Netflix. They deploy new code thousands of times a day. That speed is a massive advantage.
Then you get reliable systems. When you automate deployments and infrastructure, you remove the biggest source of errors.
Human error.
Exactly. Automation is predictable. Manual steps are just chaotic.
And you get better security, like we talked about with DevSecOps. Finding a vulnerability early is exponentially cheaper than dealing with a major breach in production. And all this automation also leads to huge cost efficiency, especially with cloud services.
I have to challenge that a bit. If the benefits are so obvious, speed, reliability, security, where does this go wrong? Because we know not every company succeeds with this.
That is the crucial question. It almost always fails at the cultural level. It's human resistance.
Mm.
Automation can feel threatening to people in traditional ops roles.
They feel like their job is being replaced.
Right. And it also demands that people learn new things. Developers need to understand a bit about infrastructure, and ops needs to understand the code. It requires a huge executive buy-in and, honestly, a willingness to see failure as a learning opportunity. That's a massive organizational shift.
So it's not just about installing new tools, it's a complete change in mindset, a move to shared responsibility. It's about systems thinking.
It's exactly right. Which brings us perfectly to the tools. We've been saying DevOps isn't the tools, but the tools are what make the culture possible. They're the enablers.
Okay, so let's do a quick run through of the stack, connecting the tools back to the problems they solve.
At the very foundation, you have things like Linux and scripting with Bash. That's the bedrock for running servers and automating tasks.
Then for version control, the thing holding the whole collaboration pillar together, you've got Git and platforms like GitHub or GitLab.
To solve that works on my machine problem, we have containers and orchestration. That means Docker to package the app.
And Kubernetes to manage all those Docker containers at scale, ensuring the system is reliable under heavy load.
Right. And to manage the servers themselves, you use infrastructure automation tools like Terraform or Ansible. This lets you define your entire infrastructure as code, which you can version and audit. No more manual configuration drift.
And the engine driving everything from code to deploy is the CI/CD pipeline. That's your Jenkins, your GitHub Actions, your GitLab CI.
And finally, to close that loop, you have the monitoring and observability tools, things like Prometheus, Grafana, or services from the big cloud providers, AWS, Azure, GCP. They give you the real-time data you need for that feedback.
Wow. Okay, that's a complex stack.
It is, and it highlights that being successful here is about designing resilient workflows, not just learning one tool. And that broad skill set is exactly why these roles are so in demand and so highly paid.
So if we pull it all together, we've gone from these siloed teams literally throwing code over a wall to a unified, automated, feedback-driven assembly line. The big win is turning slow, high-risk manual work into low-risk, continuous automation.
And that entire transition, that whole system, it rests on the feedback loop. But I want to leave you with a final thought on that, which is maybe the next evolution of this whole field, observability.
Observability. Okay, how is that different from just monitoring?
It's a great question. Monitoring tells you if the system is up or down. It gives you known health metrics. Observability, which you build from collecting logs, metrics, and traces. It allows you to ask any new question about the internal state of your system without having to write and deploy new code to answer it.
So monitoring is like checking a patient's pulse. Observability is being able to run a full diagnostic scan on any part of the body instantly.
That's a perfect analogy. Without deep observability, that critical feedback loop, the entire foundation of continuous improvement, is basically blind. It forces companies to think not just about what they measure, but how deeply they can actually understand their own complex systems in real time. That's the real competitive advantage going forward.
A brilliant distinction to end on. That's a wrap on our deep dive into the world of DevOps. Thank you for joining us.